Okay, today we are going to see the next device which is to be called as a transformer. So already I have drawn the diagram of transformer. This transformer consists of this rectangular type of core, and over that core I have wounded two coils. So first coil having number of turns N1, second coil having number of turns N2. Instead of N1 I can say NP, because it is a number of turns in the primary coil, so it is NP, and another coil is a secondary coil which having a turns NS. Now here if you are seeing carefully, your number of turns in primary is greater than number of turns in primary are less than number of turns in secondary. Secondary number of turns are more as compared to that of your primary. Now yesterday in the previous lecture we have seen the topic as a coefficient of coupling, and that coefficient of coupling K is a measure of flux which will get introduced in a coil, and we have seen when K is maximum, when K is minimum, and in that case we have seen that if the K value is equal to 1, it is to be called as a perfectly coupling, and that perfectly coupling is possible only in ideal case. And what that ideal case we have considered? Ideal case is nothing but the transformer, and that K will be 1. Possibility of K is equal to 1 if your coil get wounded on the same core. So here is that case. Here same core we have used, and over that same core, first at the left side we have wounded primary coil, at the right side we have wounded the secondary coil. Now what happens here? Whenever there is change in current through a primary coil, due to that change in current, there will be change in magnetic flux in the same coil. Due to that change in magnetic flux, there will be a production of EMF. Means what I can say that whenever there is a change in current, there is a change in magnetic flux in primary, that is phi p, which gives us the change in production of induced EMF in the primary, that is EP. Means change in magnetic flux and production of EMF is in the same coil due to concept of your self-induction. And in that change in magnetic flux, in that vicinity of the change in magnetic flux of primary coil, if secondary coil comes, then there will be a flux leakage in the secondary coil, and therefore there will be the production of change in magnetic flux. There will be induction of change in magnetic flux in the secondary coil, which is denoted by letter phi s. And due to that change in magnetic flux in the secondary coil, there will be a production of EMF in the secondary coil, that is denoted by letter Es. Now as due to change in magnetic flux in the primary, there will be a production of EMF in primary EP, which will give us a primary current IP, induced primary current. And due to this ES, induced EMF across secondary, we have a induced current across secondary as a IS. So this is nothing but the basic concept of the transformer. So while explaining what I have said, that whenever there is a change in magnetic flux in the primary coil, that flux get linked with the secondary coil. If the secondary coil will come in vicinity with the change in magnetic flux of the first coil. And this concept is to be called as your mutual inductance. So for transformer, principle is nothing but the mutual induction. This is nothing but the diagramical presentation. And how it works, that I have explained on the basis of electromagnetic induction, that is according to your Lee's law. So what I can say that, therefore I can write down value of this EP. This EP can be written as minus MP into phi p upon d, according to Lee's law. which can be written as, here this I will write down as a minus NP into d phi by dt. Similarly, there will be an introduction of secondary EMF ES, which is equal to minus NS d phi s upon dt, which can be written as minus NS d phi by dt. Got it? And if I take the ratio of these two quantities, then I am getting that EP upon ES is equal to nothing but NP upon NS. And this formula is to be called as a turns ratio in the transformer. So turns ratio is nothing but the relation between EMF induced in primary to secondary is equal to number of turns in primary to secondary. Clear? So this is the basic idea of the transformer. Now from this, already I have said that is in case of transformer, coefficient of coupling is 1. Coefficient of coupling is 1 means that case is to be called as an ideal transformer. And in ideal transformer, efficiency of the transformer, which is to be denoted by letter eta, efficiency of ideal transformer is always 100%. Now efficiency is 100% means what? The power induced, power introduced in the input circuit. Now here input circuit means primary coil. So power in the primary coil must be equal to the power in the secondary coil, that is the output circuit. So if whatever power will get generated in the primary, all power will get transferred across the secondary, means we can say that there is no loss of power. And whenever there is no loss of power, means I can say that efficiency of the transformer is 100%. And if this efficiency of transformer is 100%, means now I can write down here as a power in. Power in formula is nothing but, power is nothing but the product of voltage into current. Input circuit is nothing but the primary circuit. So in primary circuit, EMF induced is EP. Primary current is IP. So product of EP into IP is nothing but the input power. It is must be equal to now output power. What is output power? Across secondary coil, induced EMF is ES. Induced current is IS. Therefore, output power, which is nothing but the power generated across the secondary coil, can be written as product of EMF across secondary into current across secondary. And if I write this, then I can get the equation EP upon ES can be written as a IS upon IP. That I am getting from efficiency concept. So this equation I consider. Already we have got turns ratio. Turns ratio I can call equation 1. This efficiency, from efficiency I am getting this equation 2. And now if I consider equation 1 and 2, from that equation 1 and 2, combining that equation 1 and 2, I can write down EP upon ES must be equal to NP upon NS is equal to nothing but IS upon IP. Clear? So this is the important equation. This is to be called as a transformer equation in case of your transformer. Clear? I will again repeat all the things. Transformer is the device which can convert low voltage into high voltage or vice versa. This transformer device works on a principle as a mutual inductance. Third point, transformer. In case of the transformer, for ideal transformer, coefficient of coupling is always equal to 1. As coefficient of coupling is 1, so that both the coil, primary coil and secondary coil in the transformer are wounded on the same pole. So that whenever there is a change in current in the primary coil, produces change in magnetic flux in the primary, induces EMF, EP. And in that change in magnetic flux in primary, if secondary coil comes under the vicinity of the first coil, then there will be also a change in magnetic flux across secondary, which produces induced EMF across secondary. And then I can get the formula as a turns ratio as K, that is the coefficient of coupling of transformer, is 1. Transformer is 100% efficient. So I can get power in is equal to power out. From that I will get equation number 2. And if I equate equation 1 and 2, so I will get this transformer. Clear? Now the next topic under this concept is nothing but regarding turns of primary coil and turns in secondary coil. First one, if I am saying that number of turns in primary is less than number of turns in secondary, so NP is less than NS. So if NP is less than NS, means this ratio is less than 1. If this ratio is less than 1, means what? This EP upon ES ratio is also less than 1. Ratio is less than 1 means what? EP, EMF produced across primary, is less than EMF produced across secondary. But current in primary is always greater than current in secondary. Why? Because EMF in primary is inversely proportional to current in primary. So EMF is small, then primary current must be large. Clear? Means I can say that transformer is a device which will convert low EMF, high current into high EMF, low current, or vice versa. This is nothing but your transformer. And such type of transformer where primary number of turns are less than secondary, such type of transformer is to be called as a step-up transformer, because it gives more EMF across secondary as compared to primary. So it is to be called as your step-up transformer. So your line transformer, whenever you are getting a line voltage in your houses, so at the roadside, whatever type of transformer you are getting, that is nothing but the step-up transformer. While second type of transformer is there, where your NP is greater than NS. Number of turns in primary are more than number of turns in secondary. Therefore, primary EMF is greater than secondary EMF. Therefore, primary current is less than secondary. So, such type of transformer is to be called as a step-down transformer. And such step-down transformer we are going to use in our home appliances. Our all electrical home appliances works maximally on 5 volt. Only our refrigerator will works on 9 volt. So, in our house, when line voltage will come, our line voltage, AC line voltage is 230 volt, 230 AC volt and 50 Hz frequency. So, this high voltage 230 AC volt will be stepped down to 5 volt with the help of step down transformer. So like that manner, transformer device is very important in all electronic devices on electrical devices. Clear? So in transformer, principle is important, turns ratio is important. So your turns ratio already I have written here as a EP upon ES is equal to NP upon NS. This turns ratio is important. Transformer equation is important, and types of transformer, that is step up and step down. So here there is a question will get MCQ or distinguish between step up transformer and step down transformer. Clear? Or there is a large 3-mark question. What that? Describe construction, principle and working of a transformer with the help of mean level diagram. And for numerical problem, this number of equations will be there. Fine. So here our electromagnetic induction chapter get finished. Fine. So in electromagnetic induction, we have started from our phenomenon of electromagnetic induction. Then we have seen Faraday's law. Second point. Third point, we have seen the Lee's law. Fourth point, we have seen the motional EMF due to moving conductor. Motional EMF due to rotating bar. Motional EMF due to rotating magnet. That concept also we have seen. Then we have seen the concept of eddy current. After that, we have seen the concept, we have seen AC generator. From AC generator, we have switched over to back EMF. After that, we have seen self-induction, mutual induction, coefficient of coupling, and the last topic is nothing but the transformer. So this electromagnetic induction is very important topic. Right? Okay, thank you.